Hey everyone, welcome to Tuesday's lesson. Today you're going to obviously need paper and a pencil because we are taking notes. You will also need your integer chips that you picked up from school. Those are the yellow and red little circles that you got in a bag. So if you don't have those in front of you, go find those now and pause the video. So just like last time, at the top of your paper, you should add the title, including the number. So write down adding integers 1.2. Pause the video at any point during this lesson if I'm going too fast and you need to write, or rewind it and rewatch something if you don't understand. First off, let's look at those integer chips. So the yellow counters, or the yellow side, is going to be representing a positive 1. In your notebook or on a piece of paper, you would represent this by drawing a circle and putting a plus sign in the middle, kind of like how this one is here. And the red one is just the opposite. So it's the red side, and it's going to represent a negative 1. You draw that as a circle with a negative sign. Adding integers with the same sign is something that you guys have been doing for a while now. So you should easily be able to tell me what 3 plus 3 is. We should all know that it's going to be 6. But how do I prove it using those integer chips? So I see that I have a positive 3 plus a positive 3. So I'm going to represent that as 3 positive 1s plus 3 positive 1s. You can see that they are all the same color, so we're just going to add them together. And that gives me 6 positives total, which makes sense because we know that the answer to 3 plus 3 is a positive 6. It's the same exact thing with negatives. So we have negative 4 plus negative 2 in this problem. We're going to use the red side of the counters this time and represent the negative 4 with 4 negative counters and the negative 2 with 2 negative counters. Again, since they're the same color, we're going to combine them, and we know that the answer to negative 4 plus negative 2 is going to give us a negative 6. To be able to work with numbers that have different signs, we have to understand the concept of a zero pair. My first question to you is, what is 1 plus negative 1? You should be able to tell me that it is 0. That is our zero pair. So when you add a positive integer, or one of those yellow counters, and a negative integer, or one of the red counters, the result is going to be 0. So it kind of cancels it out. So if we're looking at this problem that has integers with different signs, the first thing that we should do is lay out our counters so we can see a visual representation of this problem. So I've got 3 negatives and 2 positives. So I'm going to lay it out kind of like this so I can group them up. We're going to use that idea of zero pair and cancel out some numbers so we can get rid of some integers. You're going to take away those zero pairs. So it's going to look something like this, because negative 1 plus positive 1 gives us a 0, and we know anything plus 0 is going to be itself. So we're going to take those away. At the end, you should be left with only one color. So in this case, we only have one red integer, which means that we have a negative 1. And that tells us that negative 3 plus 2 is negative 1. Our second problem is 3 plus negative 7. Again, the first thing that we're going to do is lay out those integer chips. If you feel comfortable moving forward without my help, pause the video now and solve this problem. Once you're done, play the video again and check your work. If you don't feel comfortable, please follow along with me. So our integers laid out are going to look like that. I've got 3 positive and 7 negative. Again, the next step is canceling out our zero pairs. We're going to get rid of them. So I cross them out like that. We're only left with our red colors, and I have 4 red integer chips. So that means that I have a -4. So that tells us that 3 plus -7 equals -4. Now it's your turn. Try these 3 problems by yourself, pause the video, and then check your answers when you're done. Here are the answers to those 3 problems. 1 is -4, 2 is 2, and 3 is -5. So this is a little cheat sheet that I have up in my classroom for basically the whole year for any student that needs to look up and reference it, because we will be using this idea of zero pair and subtracting or adding integers of the same sign and of different signs a lot at this year. So when you're working with integers with the same sign, we are going to be adding the numbers and keeping the sign. So if you look at problem number 3, where they have the same sign, we take 1 plus 4 and we get 5. They both are negative numbers, and so we're going to have a negative answer. With our different signs, all we really did was subtract the numbers. So 7 minus 2 gives me a 4. 5 minus 3 gives me a 2. And then I kept the sign of the bigger number. Looking at the number 7 and the number 2 without looking at their signs, I know that 7 is bigger than 2. And so that means since my 7 has a negative in front of it, that my answer is going to be negative. It's the same idea with number 2. I'm looking at a 5 and a 3. Comparing 5 to 3, I know that 5 is bigger. Since 5 is a positive number, my answer is going to be positive as well. Now let's go in and look at some of your homework that I'm going to be assigning you. So this is the front side of your homework. I'm giving you 8 different problems to do. It says for problems 1 through 4, create a model with your counters, and then draw a picture of your model and answer the question. For problems 5 through 8 down here, you're going to be solving the problem without using your counters or drawing pictures. So you're going to be working through those 8 problems. On the back side, we have a fun little challenge called the Magic Square Challenge. The directions say in the magic square, the numbers in each row, column, and diagonal add up to the same magic number. I tell you that in this first magic square, the magic number is going to be a 3. So I know my magic number is a 3. If I wasn't told that, what I would do is I would look at a complete row, column, or diagonal. So this is a row, this is a column, and that's a diagonal. Since this is complete, I can add all 3 of those numbers together and figure out what the magic number is, because each row, column, and diagonal should add up to the same number. So I'm looking at 3 plus 1 plus -1. I know that 3 plus 1 is 4, and 4 minus 1 is going to give me a 3. So I know that my magic number is correct. Next, you have to start filling in the blanks in our magic square. So I'm going to look at rows, columns, and diagonals that have 2 numbers filled in and 1 blank. Using that information, I can figure out what that blank is, knowing that my problem should equal 3 at the very end. So if I'm looking at this diagonal right here, I have 2 plus 1 plus some number is going to equal 3. I'm going to add those two numbers that I know together. So 2 plus 1 gives me a 3. I still have my blank right here, and I know that it has to equal 3. I know that this number is always already 3, and it has to equal 3. So the only number that I can fill into this blank is 0, because 3 plus 0 equals 3. So I'm going to fill this in with a 3, or with a 0, I'm sorry. I can double check myself because I have this one complete too. So 4 plus -1 gives me a 3. 3 plus 0 matches up to my magic number of 3. Next, I'm going to do that row. So I have 2 plus a blank plus a 4 should end up equaling a 3. I'm going to combine those two numbers. So 2 plus 4 gives me a 6. I still have my blank, and that's going to equal 3. Now I have to think about what number I can add in there to get it to equal to 3. The only number that's going to work is a -3, because 6 plus -3 equals 3. So I'm going to write in a -3. Finish working on this magic square and pause this video now. In a second, I'm going to give you the answers to these two blanks. And there's our completed magic square. Now we can move on to problem 2. If you have any trouble completing the magic square or the front side of this worksheet with these problems here, please email me. Also, please try these problems, especially the magic square, before our Zoom meeting later today.